In this video, we are going to see about the next deletion case, that is deleting the node at the end. We are going to delete the node at the end. So here also we have to use one condition, that is while ptr tends to next is not equal to start. Okay, this condition we have to use. If this condition is true, means we have to execute that statement ptr tends to next. Okay, if it becomes false, means what we will do, means it contains the address of the first node, and here it contains the address of the last node. So suppose it is 100, and if it is 150, means it contains the address as a 150, and here it contains the address as a 100. So we will see the algorithm. So this is the algorithm. First we are checking the underflow. Then what we are doing, we are assigning ptr is equal to start. So this is the ptr node. Then we have to check the condition. So that is, we have to repeat the step 4 while ptr tends to next is not equal to start. Till this condition getting false, the step 4 will be executed repeatedly. So in the fourth step, it is given ptr is equal to ptr tends to next. So we will check the condition. ptr tends to next is a start node. So it is not a start node. So we have to execute the statement ptr is equal to ptr tends to next. So this is a ptr. Then we are checking next is a start node. No. So it is a ptr. Then we are checking ptr tends to next is a start. No. So this is a ptr. Then next we are checking next is a, we are checking here it is a start node. ptr tends to next is a start node. Yes, it is a start node. This condition becomes false here. So what we have to do, we have to execute the statement ptr tends to previous tends to next is start. Okay, so ptr tends to next. Okay, ptr tends to next. What is the next node? So this is a next node. Next node's previous. Okay, next node's previous. So this previous is equal to start. Okay, sorry, ptr node, this is a ptr node, the previous node is this. So this previous node's next, so it should be a start. So for example, the address is 100 for this, and consider this is a 150. So what will happen here, it will be the 100. How it is 100? So the statement given ptr tends to previous. So ptr tends to previous. Previous means this part. This previous addressed next. So next means here it is equal to start address. So what is the start address? It is 100. Then next, start tends to previous. Okay, so the start node tends to previous. It contains address of the ptr's tends to previous. So this address. So it contains address of 150. Then by using the free function, what we are doing, we are removing. Okay, so what will happen? So it will be connected like this. Okay, this is simple only. Then when you are writing the code, struct node, we are using one pointer variable, that is a ptr. Then we have to assign ptr is equal to start. Then we have to check the condition while ptr tends to next is not equal to start. Next is not equal to start. If this condition is true, means we have to execute ptr is equal to ptr tends to next. If this condition becomes false, I have to execute the statement ptr tends to previous tends to next is equal to start. Then start tends to previous is equal to ptr tends to previous. Then by using the free function, we are removing this node from the list. Okay, we are removing from the node. Then we have to return the start. Okay, so this is the code for deleting the last node. So here we are checking this condition. By using this condition, we have to find the start node, and we are deleting the last node from the list. So this is about the circular doubly linked list deletion.